Okay, we're back with the inverse lesson here, the part 3, I guess, if we consider the little helper video there. A couple of things that he mentioned, and it'll come up in today's lesson, that some of the inverse functions you can find easily. Like we've been talking about pairs of functions ever since you started doing math, right? What's the undoing function of adding 6 while it's subtracting 6? And one of the things I want to mention is um, the guy, the English dude, kind of used the mapping notation to talk about this. For the operation adding 6, if we start with an input, and it doesn't matter what the input is, and the operation f is adding 6, right? And these are the y's. And this is a nice way to think about functions, is in this mapping notation. And maybe that's new for us, probably not, but it's nice to see. And then this opposite operation, the inverse function, undoes that, right? Subtracting 6. I start with an input of 10, subtract 6, I get back to 4. And this is a nice way to think of inverse functions, where the domain and the range, they kind of switch places. The domain of the inverse function is the range of the original function, and so on. So let's go through these. These are what he would, in the other video, the helper video, would call the easy ones. Dividing by 6, what's the opposite? Multiplying by 6. So for this one, another easy function, subtracting 5, well, the inverse is adding 5. Here, the function multiplying by 3, the inverse dividing by 3. And no problem. These ones are one-steppers, easy to see the inverse function. I'm going to go on a little bit of a rant here. I hope you don't mind. And it's got to do with this notation. I want you to be clear that this is just notation. It means the inverse function. Why it's kind of confusing is because if we saw that on a number or on a variable, we'd think of this as not an inverse function, but as an exponent, right? An exponent where the exponent minus 1 means for you to do that, right? It means for you to flip it and become a positive exponent. But when I think of this, it doesn't mean this. That's not true. You know, this, depending on, this means the inverse of sign. And we're used to hitting that little inverse button. The f at minus 1, it means the inverse function. It doesn't mean reciprocal. It doesn't mean the same thing when we're dealing with numbers or variables. So be careful there, okay? I wish they would have picked a different notation, like fi for inverse or something like this, because it's easy to get confused with exponents, but please do not. Don't get confused there. Okay, rant over. Let's get on with the next example. So here's the lesson. And we saw from the video there were basically 2 steps in finding an inverse algebraically. We switch x and y and then solve for the other variable. And he called it make x the subject, solving for y. That's how we make x the subject. So if we wanted to find the inverse of this, and some of you might be able to get it, some of these ones straight off, but I'm going to use the algebraic technique. So the first step is to switch x and y, and then I'm going to solve for y. So how do I solve for y? I subtract 3 from both sides, and then I divide by 2. And the 2's disappear here, so I get this function. By the way, this is just a line. This is a line here, right? Slope is 2, y-intercept is 3. This one is, if I thought about dividing each part by 2, this is actually a half x minus 3 over 2, right? So it is still a line, even though it's not that familiar of a form. In this one, now, when I switch x and y, there's actually quite a few steps to do here. right? So, oh, by the way, this was step 2, right? Was solving for y. So the first step is easy, switching variables. Now this is the inverse, right? Oh, that should be a y there. This is actually the inverse already, but now we want to put it in that familiar form where we solve for y. What's the first step? Well, I know I'm going to have to square root at some point, but I got to wait until I can do that. Subtract 4 from both sides. So this is solving for y. Next step is to get rid of the half. How do I get rid of the half? I multiply. Multiply both sides by 2. I could divide by a half, but dividing by a half is the same thing as multiplying by 2, so I see this as a lot easier. And now I've got a square root. Now notice when I square root something, there's actually 2 answers. Remember this from last year. There's the positive and negative square root of 25, or positive and negative 5 are both answers to this. So I got to be careful. Here, when I take the square root, I get the square root of this. And this is kind of strange, having this positive. It means there's 2 pieces. Now I could have y is equal to the positive of all this, and y is equal to the negative of all this. Finally, adding 5 to both sides. And there's my inverse. It's not really a function, actually. And we'll talk about this real quick. But what does this mean? We were just asked to solve for this function, find the inverse function algebraically. But what is this? This original thing is a parabola, right? It's a parabola which vertex is 5, 4, 5, 4, and you don't have to necessarily copy this down, but its inverse then is a parabola that's sideways, and there's actually 2 pieces. We see this is the square root function that's been horizontally compressed, moved to the right and up 5, and so it's it's somewhere around here, like that, and then the negative is this side of it. All right, so there are actually 2 pieces. This isn't even a function, this inverse. So there is a little bit of an issue here that we're not sure about, right? Question mark. And we'll see this actually in the next example. Graphically, remember, the inverse is a reflection in the line y equals x. And we saw this last year. And so if we wanted to graph this, this is the parent function, square root of x, that's been moved right 2 and up 1. And this is very similar to the last example we'll see. So I'm going to get some scale going here. There we go. A little bit of scale. My original function, I'm not going to draw the parent graph. I'm just going to graph this one. Hopefully you're okay with that. It's not been stretched or anything. So right 2 and up 1, and then half a sideways parabola. The square root function, there we go. That's, what was the letter? F at x? Yes. F at x equals the square root of x minus 2 plus 1. It says state the domain and range of f. So I'm going to do some work over here. The domain of f is all the variables, or all the values of x that are allowed. Notice that if I just use the graph, it's all of these ones. It's x has to be greater than or equal to 2. And I can see that algebraically as well. I don't want to be taking the square root of a negative number, so there's the domain. The range, if I think about it from the graph, it's all the values of y that are allowed, and I see it's going to start at 1 and go all the way up y has got to be greater than or equal to 1. And again, algebraically, I can see that because the numbers that come out of a square root are at worst 0. And then I add 1 to that, and I get my range. It says find or state the inverse graphically. So what this means is I'm going to use my graph and reflect in the line y equals x. That's this line right here, right? It goes straight up. That's this line right here, y equals x. And then I'm just going to reflect this in this line, right? And in fact, one way to think of this is these points from the original graph what's this? This is 2, 3, 4, 5, 6, 3. X and Y switch places is one way to think of it. So this point on the inverse graph is going to be 1, 2. And in fact, I can see 1, 2 is just a reflection. And some people are really good at being able to reflect something in a line like this. Other people will just actually switch the values of X and Y. There's 1, 2. There's 2, 3. And then 3, 6. Well, geez, if I wanted to do this graphically, that's kind of tough to see, but I could go kind of like a square and a half diagonal there, or I could just graph the point 3, 6. And I see there's the inverse graphically. And in a second, we're going to actually get the formula for the inverse algebraically. Now, could I figure this out anyway? Well, this is half of a sideways, or this is half of a real parabola. I can see the pattern over 1 up 1, over 1 up 3. It's unstretched. I know it's got that as the parent function, and it's been moved right 1 up 2. Right 1 up 2. That's its formula, isn't it? But we'll save that for when we actually do part D. So this is C is on the graph, and D, I know it's going to be this. But let's show that graphically, or sorry, algebraically. So where am I going to do the work here? I want to save some room here, so I'm going to do the part D right here. Part D is, I'm going to start with my original equation, right? Change x and y, and then solve for y. Subtract 1. How do I get rid of a square? I square root. Or how do I get rid of a square root? I square. Move that down for a second. So that becomes y minus 2, and then add 2 finally. And there's my inverse graph. Now there is a bit of a problem here. And the problem is, this is an entire parabola, right? This is both sides. So how do I say that I only want half? I only want half of this parabola. Well, I make the domain restriction that I only want half the parabola. I only want x is greater than or equal to 1. Half the parabola. And in fact, that's the second part here. State the domain and range of the f inverse. The domain is x has got to be greater than or equal to 1. And what's the range? Y has got to be greater than or equal to 2. And notice what we've done here. The domain became the range, and the range became the domain. Well, that's exactly what an inverse does, right? X becomes y, y becomes x, the domain becomes the range becomes the domain. That's exactly what an inverse is. There's one more little bit of business before it's homework time, and that's for you to read an example on example 4 on page 42. This is kind of an application type question, I believe. It says take notes if you like. That's probably a good idea to take notes. There's the homework, and the FAQ is on inverses as well.